that's where you sometimes replaced a cos squared, or you placed a cos 2x or a sine 2x, right? And then you had to solve it. With solving, I could give you a restricted domain. Or, instead of a restricted domain, I could ask for a general solution. Number 2, what we went over was non-permissible values and verifying, right? So we went over non-permissible values. And the only time you didn't have non-permissible values, it's permissible, able. Is it an I or an A? My brain has stopped. I think it's an I. Permissible. Type it in your phone. See if it autocorrects you. Let's go. I know you have them near you. Permissible. I think it's an I. It's an I, isn't it? But then it made me like question myself. It's an I, right? I know. Permissible. That looks ridiculous. But they both look ridiculous. What's an I? I think. I'm going with it. Non-permissible values. I should have just went with restrictions. That I know how to spell. I'm a really good speller. It has to be an I. That's how I wrote it the whole time. I can't be an A. That just looks. Is it an A or not?
I don't know. So you didn't tell me.
It's an I.
Okay. Jacob said it's an I. Megan has now affirmed it's an I. And I looked at it and said it has to be an I because that's how I wrote it my whole life. And it would be like a lie. My whole life would be a lie if that was an A. But I thought like able. It would be like A-B-L-E. And then I was questioning myself. English language. Okay. Non-permissible values, restrictions, you only have them when it's not a sine or a cos, right? If you have a secant, you have a non-permissible value. If you have a cosecant, if you have denominators, right? If you have sine or cos in the denominator, if you have tans, if you have cotans, all of those will get you non-permissible values. 3, we did verifying. And when you verify, remember what you do? You instantly rewrite the question, and then you put that value in for x, right? And go right to your examples, or to your unit circle, and pull the stuff off of it. Bless you. Left side stays on left side, right side stays on right side, or you get zapped by a lightning bolt. Okay. 4, we did sum and difference. And double angle identities. We reviewed a lot of that yesterday. So that's where you have like tan 75 or something like that. You have to use 35 or 30 and 45, right? Or tan 15 or any of those, and you have to use that formula. Or it could be where we had to, I gave you like cos 15, cos 35 minus sine 15, sine 35, and you had to write what that would be as combined, right? Or I gave you ones where you'd have to make the triangles, the A triangle and the B triangle, and then use sum and difference formulas, right? We went through those. And then the last thing we did was proofs. So that's basically chapter 6 in a nutshell. Okay? So today we're going to do a little bit of verifying and proofs because we touched on the other ones all yesterday. Okay? And the day before. So I'm going to get you to verify this one. Verify cotan x minus 1 over tan x minus 1 equals negative 1 over tan x for x equals pi over 3. So you try that one out. Okay, this one we're going to go cotan of pi over 3 minus 1 over tan of pi over 3. Please don't dismiss the filling the pi over 3 in, right? Because if you just literally go to the exact values and don't fill in the pi over 3, you're not verifying that this is for pi over 3. You're verifying for I don't know what, because me marking doesn't know that you know that that's pi over 3. Okay, so make sure you write the pi over 3. Equals negative 1 over tan of pi over 3. What's cotan of pi over 3? Root 3 over 3? Minus 1. Oh, I get a fraction, so I'm going to write it sideways, my numerator beside my denominator. Tan of pi over 3 is root 3. Remember, you can memorize them, or you can literally go, okay, tan of pi over 3 is sine of pi over 3 divided by cos of pi over 3, which is root 3 over 2 divided by a half, which is root 3 over 2 times 2, which is root 3. You can do all the math for it, or you can memorize it. Cotan is just the flip of that. So we get root 3 minus 1. This is technically over 1, equals negative 1 over root 3. We can't flip the right-hand side because the left-hand side is not a full fraction, correct? It has to be full fraction divided by full fraction before I'm allowed to flip. So I have to make this one a common denominator. So I'm going to multiply by 3 and 3. So I'm going to get root 3 minus 3 all over 3. Then I can flip it. Times 1 over root 3 minus 1. I'm not sure why I put that in brackets. Negative 1 over root 3. This is looking cray-cray. That's what this is looking like. So then we go root 3 minus 3 over, then the 3 we get distributed, so 3 root 3 minus 3, because that'll go into there, equals negative 1 over root 3. We're going to have to multiply by the conjugate. 3 root 3 plus 3. So we get 3 times root 3, which is 9, because 3 times 3. Then negative 3 root 3 minus 9 root 3. And then plus 3 root 3 minus 9 over 3 times 3 is 9 times root 3 is 27 minus 9 root 3 plus 9 root 3 minus 9 negative root 3 over 3. So then I get the 9's canceling. I get negative 6 root 3 over 27 minus 9, which is 18. Take a 6 out of both. Ah, Savannah! It's matching. We are happy. Because I'm happy. That song should play. Yeah, it's good. It's by Justin Timberlake. I need to have it queued up. So then when we get like a left side equals right side, I just play it. So I'm going to do for your proof, for the next proof. They match. Why do you give me that look? They're happy because you'll find out. You'll know. It's fine. It's from the Trolls. It's not actually, but that's what I remember it from. Because I'm a mom of little children. So it's a troll movie song. Is it a Despicable Me song too? I should know that. Because we've watched every freaking version of that too. I've shamed my children today, not knowing that that is part of Despicable Me. I apologize. I don't know what kind of mother I am. Shameful. I'll try harder later. All right. You guys are going to try this one. These are going to be proofs. So prove. Secant squared x over secant squared x minus 1 equals cosecant squared x. And 2 1 minus cos x equals sin x. 1 minus cos x divided by sin x equals tan x minus sin x over tan x sin x. And I'm assuming you're all going to do it different than me. So that just happened. There you go, Eilish. Nothing that's perfect. Sine squared x equals 1 over sine squared x. Left side equals right side. All right, good times. Now what about 2? What can we do? I'm going to leave the left-hand side. And then I'm going to switch this into sine x over cos x minus sine x. Oh, I'm getting fractions. Brackety bracket. Divided by tan x sine x. So sine x over cos x times sine x. Not full fractions. We'll leave this. Equals common denominator cos x. So I get sine x minus sine x cos x all over cos x divided by sine squared x over cos x. 1 minus cos x over sine x equals, I can take a GCF out, sine x 1 minus cos x over cos x. Now I have full fraction divided by cos x over sine squared x. Got a frog in my throat. Boom, boom. Boom, boom. Oh, 'cause I'm happy. Oh, it's recording. I forgot. Only Eilish would still listen to that.
I get copyrighted. You sound much like.
I know, I sound just like Pharrell, who I thought was Justin Timberlake. So I think I sounded more like Justin Timberlake than Pharrell, so we're okay. I don't think I sounded like either. I have a manly voice, though, so maybe. Left side equals right side. Boom. Shakalaka. Okay, I'm going to post the review, like I said, the one that I have, as extra practice for you if you want to. There's also practice out of the textbook, but I find the textbook is kind of, in this proofs part, is kind of written weird. So I just, if you want to practice proofs, just practice the ones that I have. Now, I have an answer key to it, but you have to remember that just because I do it one way doesn't mean that's the only way it can be done, right? Don't go like feverishly erasing yours if your math is correct. You might want to, on Monday, though, come to me and say, is my math correct? Because sometimes you do some illegal math and cross off random stuff and get things to match, and none of it was right. So you can check it that way, okay?